Thank you. So, hey everyone, I'm Paul. So, as Sergey said, I do web performance work at Etsy, and I'm a co-organizer of this meetup, but I also am a co-maintainer of the HTTP archive, and I'm really excited to talk to you about this today. So, the HTTP archive is an open source project. It tracks how the web is built. It tracks how the web's evolved over time. It started in 2010. Steve Souders had started it. For those that are familiar with or have been in the web performance industry for a while, you've probably heard his name. He wrote the first web performance book. It was one of the books that Sergey shared on one of his slides before. What he wanted to do in 2010 was to create a digital archive of technical information about the way the web is constructed. So we already have that for visual aspects. Like you can go to archive.org and look at the Wayback Machine, and you can see like what eBay looked like in the 1990s. But the technical aspects, like what the CSS looked like, what the when web fonts started being used, when video started showing up on web pages, all of that was not being archived or tracked anywhere. So he started out with about 1,000 websites. It was the Alexa top 1,000 websites, and every month he collected that, and the archive grew over time. Today, the archive uses the Chrome User Experience Report, which is Google's realm data, as the basis for the corpus for the URLs that we track. So that starts with about 15 to 17 million URLs. Then what we do is we run web page test measurements on each one of those. So we're doing that for desktop, mobile for the homepage, and then we're doing desktop and mobile for a secondary page. The secondary page is chosen dynamically. It's usually the link that is like the largest contentful paint element. But so, yeah, we basically have about 60 million web page test measurements that get run in a very short amount of time. And all of that data gets stored in Google's BigQuery. So that becomes immediately searchable. If you've ever looked at like the underlying data set of a web page test measurement, it's all HAR files or HTTP archive files. So those HTTP archive files are essentially brought into Google BigQuery. From there, you can query the data in BigQuery, and we're going to look at that today. And there's also a website, so httparchive.org, where you can look at like monthly trends. There's a discussion forum. There's also the Web Almanac, which I'll talk about in a minute. The discussion forum is actually where I got my start kind of digging into the HTTP archive data. I saw a conference talk back in 2013 about like when the archive was first available to be queried in BigQuery, and it was just fascinating, and there was so much great discussion happening in that forum just about the data and what you can do with it. The Web Almanac is a community authored ebook. So this is published every year. It was the 2025 edition was just published, I think about a month and a half ago. It's a free ebook, and it's written by members of the web community. There's chapters on performance, CMSs, CDNs, fonts. I think there was like, there's 16 chapters in the Almanac. I had worked on in 2019, I worked on the caching and compression chapters, but every year we try to get new people to write for the Web Almanac. It's important to introduce kind of new thoughts and new ideas into it. So if anybody's, after this talk, if you're interested in contributing to the 2026 edition, let me know and I can help you get started. So this is an example of one of the, like if you go to the HTTP Archive's website, there's some reports, and this is one of the reports that you would see. It's the total number of kilobytes delivered on a homepage over time. And so what you're looking at here is 2011 to 2026. And you can, and the solid lines are the median statistic for desktop and mobile. So you can see that when we started collecting this data, end of 2010, there was about 0.5 meg of page weight for desktop pages. And today, at the median, it's 3 megabytes. The shaded areas is the 25th percentile and the 75th percentile. So the entire area within that shaded portion is really 50% of websites. That means that there's 25% of websites that have a homepage that's larger than 6 megabytes, which is kind of shocking. This is the total number of requests. And if you look at the two side by side, it looks kind of different. Like the number of requests per page was increasing up until 2016, and then it just kind of leveled off. This is kind of where it starts to get really interesting and where you might get some ideas about how to dig into the data, because you can probably find the answer to this question in the data. Maybe there was video that was being introduced or larger images, but there certainly isn't more images. There certainly is not more content. Maybe larger JavaScript assets, with frameworks and whatnot. But there's two very distinct patterns here. We've got a literally increasing page weight, but the request count per page is kind of flatlined. Tim Kadlik, who works at Cloudflare, wrote about this last week, where he said the P75, so the 75th percentile and the 90th percentile of JavaScript bytes on the web has actually exploded since May of 2025. And he said it's the largest 10-month period in the HTTP archive data since 2023. And then he joked, Gemini, what happened in May 2025? And so what happened was that was when coding agents were introduced. And so you can see kind of a direct relationship between coding agents and bloated web pages. So it's AI is going to keep us all happily employed, I think. But this isn't the first time we've talked about page weight getting out of control. So this was 10 years ago. So in 2016, Wired magazine wrote an article using HTTP archive data where they showed that the average size of a web page was actually approaching the size of the original Doom video game from the 1990s. So it was 2.4 meg. It was shareware. You can spend like a couple of hours downloading it on your modem, but it was you were delivering more bytes to load a web page at this point. I decided to take a look at the stats again. Now, in the archive, since the archive has grown so large to the point where we're looking at like millions of websites, we no longer look at the average size, but we look at like medians and percentiles. But for the sake of comparison, the average desktop web page is 5.5 megabytes. So it's almost 2 Doom installations. It's also about the size of the complete works of William Shakespeare by William Shakespeare. Now, what's also funny is that this is the uncompressed size of the William Shakespeare byte, so it's probably like 10 times the size of William Shakespeare's delivered content over the web. Now, all of this is just stuff that you can get from browsing the website and looking at some of the curated stats. But the real power in the HTTP archive is the raw data. So there's so much data. We're collecting petabytes of data about the web, and all of that is available to query. Now, with great power, comes great chances of blowing out your Google Cloud bill. So we're going to talk about like how you can set appropriate like budgets and alerts and whatnot to avoid that. But there's a really cool reference guide that Rick Viscomi had written. Rick Viscomi was one of the previous co-maintainers of the archive. It's called har.fyi, and this is a documentation for the HTTP archive data format. It's got some guidance on how to write efficient queries, how to query the different tables and the different data structures within the archive. So to get started, and there's a link to the Getting Started guide here as well, but you need a Google Cloud account. You don't have to pay for a Google Cloud account if you want to get started with just like an account without billing, but you need an account and you need to create a project. When you have a Google Cloud account in your project, you can navigate to the BigQuery console. So BigQuery is a massively distributed database that allows you to run SQL across gigabytes or terabytes of data. And then there's a little button over here that says Add Data. You click that, and then you'll see like a bunch of different public data sources that are available. For the HTTP archive, you choose to star a project, and then you enter the HTTP archive. At that point, you have the HTTP archive tables in your BigQuery view, and you can start writing SQL. There's two tables in the HTTP archive. This is much more simplified than it was a few years ago. There's a pages table and a requests table. And each of these tables has all of the data going back to 2010. So the data is partitioned by date so that like you're not querying like 2 petabytes of data. And then it's clustered by things like client, like desktop or mobile. Is this a root page or secondary page? The rank of the site, so the popularity rank. Is this a top 1,000 site? Is this a top 100,000 site? And so forth. But there's some summary stats, and then there's a bunch of arrays that have things like custom metrics or lighthouse tests. You can look and run queries again to see like how many websites fail a particular lighthouse audit. The same data exists for requests, and that's you can look at every request header and response header across all of these websites. You can even parse the response bodies, although that is prohibitively expensive. So I put a little warning icon next to the things that you should be really, really careful about querying. And this is an example of a simple query, and it's looking back at that first example I showed you, which was the average page weight. So in this case, what you can see is I'm selecting from the HTTP archive crawl.pages table, and I'm asking for from the February 2026 data set, just root pages to give me the count of the number of sites in the data set. This is where you can see there's like 15.7 million mobile sites. And then from the summary, I want to grab the number of bytes total delivered on the page, convert that to megabytes, and I'm casting it as an integer, averaging it, rounding it, and then we get the stats. So fairly straightforward SQL query to, now the one thing that you'll also notice here, it says this query will process 54 gigabytes worth of data. So that's the amount of data that BigQuery has processed in order to return those results, and that's the amount of data that gets billed for. Google BigQuery has a free tier, which is 1 terabyte per month. So you can run this quite a number of times before you start running up charges. But if you were to like write a query and you see this query will process 1 terabyte of data, then that's going to start costing real money. So it's really important to understand BigQuery's cost model. So there's two cost models. One is the one that's the most common is on-demand pricing. So the first terabyte is free. Every terabyte afterwards is $6.25. So ironically, what this also means is that writing more efficient queries saves you money. So not only will it be faster, but it will save you money. There is other, like your employer might have, like if you use BigQuery a lot at work, you may actually find that you have like either different pricing or different different cost models. Like for example, when I'm working with BigQuery, it's based on slots. So there's a certain limited amount of capacity and you can use that, but you can run as many queries as you want within that time, within that capacity that's allotted. But yeah, this is what, like if you signed up for a Google Cloud account, this is what the billing would look like. So you could set up quotas to limit accidental query costs. So this is on my personal accounts, and you can see I've set a quota that basically says I don't want to use more than 1 terabyte per day. So it will notify me, like it will prevent me from using more than 1 terabyte per day. It will just fail the query. You can also set up alerts, because 1 terabyte per day is still 30 terabytes, and that's a lot of money. So I can set, like in this case, I set a budget for $25, and then I will get notified when I hit 50%, 90%, 100% of that budget. So with those two cost controls in place, you can, or just not enabling billing, you could avoid overages. In the har.fyi site, there is a section on minimizing query costs. So there's a couple of different approaches. Like you can limit, well, you can filter out by rank. You could use BigQuery's table sample feature, which just randomly samples the data set. Or we have a set of sample data that you could analyze. There's pros and cons to all of that. It's all explained in the documentation. If anybody is digging into stuff like this and they want they want help or opinions, you can reach out to me, or you can go on the discussion forums, and there'll be folks that are happy to share. So this graph here is actually also from the curated stats, and this is showing lazy loading, like the adoption of lazy loading across the web. So the loading equals lazy tag. What you can see here is that in 2020, lazy loading feature was available. That was when it became part of the HTTP specification. And you can see that right now, about 40% of websites are using the lazy loading feature. So it's gotten really, really strong adoption. Let's say I wanted to run a query based on this, and I wanted to look at maybe, let's say, native lazy loading for sites that have more than 50 images on a page, right? So right next to all of the graphs that you find in the reports, there's like a hamburger menu where you can click Show Query, and it will take you to GitHub, where you can actually see the query that was used to run that. In this case, you can see that this is the query that was used to create the data for the report that you're looking at. The same is true in the Web Almanac. So if you're looking at the Web Almanac, any of the graphs that you see in the Web Almanac, you'll see like 3 dots, and you can click to view the query. You can also look at the data as well, and so that if you query, it'll show you it'll show you a GitHub file, a hosted file that will have the query in it. If you click View Data, it'll open up a Google Sheet where the analyst that created this graph actually took the data and created the graph from it. So you'll actually be able to see not only the results of the data that they ran, but also how they manipulated that data in order to create the graphs. There's also HTTP archive data in the Chrome status website. So this is a website that shows like web features and usage metrics. So if you've ever looked at this site before, where you can see like different web platform features and the adoption over time, you can that's actually all coming from HTTP archive data. So for example, here is speculation rules. Speculation rules is a really cool feature that was added, it's been around as an origin trial for a little while, and then it really started gaining some adoption last year. But you can actually see that in June 2025, that's just like really took off. It went from like single digit or like 1 or 2% of websites to 10%, and upwards of like 15% or 14%. The reason for that was actually because WordPress implemented speculation rules, and so 15% of the web started using speculation rules. But like you can see this data in that, and then you can also see the SQL query. So if you wanted to go and run like SQL queries against this data to try to see like what's the adoption out without WordPress and things like that, you'd be able to analyze that data. There's also something called the Core Web Vitals Tech Report. So the Core Web Vitals Tech Report is linked to from the HTTP Archives website, but it allows you to choose different technologies, and you can see the adoption of those technologies, as well as, based on Chrome User Experience Report data, the performance of websites that use those that use those particular products or features. So in this case, this is looking at JavaScript frameworks, and you can see that React is the most popular JavaScript framework. It's Core Web Vitals, only 46% of the websites pass it. When you look at like Next.js, 31% pass it, and so forth. Surprised to see Require.js was at 65%. But yeah, so there's this data here is also has the SQL queries on the pages as well. And then just yesterday, or I guess, 2 days ago, so Max Ostapenko, who's also one of the co-maintainers of the HTTP archive, had published an MCP server for the HTTP archive. And this is 2026. Like, I would be negligent if I did not include something about AI in a presentation. And I've gotten away so far, so here we go. So this is an MCP server that actually integrates with the tech report, where you can actually go and add it to your AI agent of choice, and then you can do something like say, what are the most popular e-commerce platforms, and it'll give you the summary from the data, and then you can go and start saying like, what are the most popular e-commerce platforms that are using Cloudflare, and just kind of dig in a little bit deeper into the data. So it allows you to kind of explore some of this data, and this actually doesn't cost anything because it's MCP. It's not actually using you use your AI credits, but like you're not actually the one running the SQL for this. So I wanted to show a couple of I have a couple of SQL queries that I can show you. I ran them ahead of time just because live demos are fun. But I'm happy to rerun them if you want to see them run. But this is an example of just counting the number of sites and the number of requests for the March 2026 data set for just mobile home pages. And you can see there's 15.8 million websites or mobile websites in the data set. There's actually 1.5 billion requests. So if we're looking at like HTTP requests, there's 1.5 billion requests here. Here's another query where I decided to take a look at the for mobile root pages, specifically for pages that were in the top 1,000 websites. I wanted to find images that had that had a cache control header, and I wanted to see what those cache control headers contained. So in this case, this is cacheable for a certain number of seconds. This is not cacheable, and so forth. The next thing I wanted to do is try to identify websites that had a had a cache control header that indicated that an image should not be cacheable. So this is no store or max age 0, meaning cache it only for 0 seconds. And I found 14 websites in the top 1,000. If I were to comment this out and run this, now this is going to run 394 gigabytes of data in order to run this. This will count the number of websites that have an image, at least one image, that has cache control no store, and there's 413,000 of them. And that seems like really, really large. I wrote another query where I limited this just to first-party data. So in this case, I included in my, where is it? Actually, this one is not the right query, but the first-party one showed a much smaller number of, I could probably pull it up here. First-party, unless I put the, yeah, here we go. So, and the page is equal, the host name for the page is equal to the host name for the URL. So that's 320,000 websites. So 320,000 websites have at least one image that is at least 50 kilobytes that is not cacheable, which is kind of crazy. We can also look at this by rank. I thought I ran that query, but I guess I didn't. Oh, there it is. We can look at this by rank and just look at the different popularity ranks. So 11 websites in the top 1,000 websites are loading images without caching them. 52 in the top 5,000, 86 in the top 10,000. So there's some large sites that are not caching their images, and that's like a super easy web performance win. But the power of this data just kind of allows you to really just kind of drill down and explore that, and really like try to look for those trends and things that you can questions that you can answer about the web. All of the there's a bunch of links in the slides. So the HTTP archive website, the forum, the MCP server, the almanac, all the information on how to get started, and some of the example queries. But yeah, that is my introduction to the HTTP archive. Any questions?
Hey, thanks so much for the talk.
Sure.
And HTTP archive is a super important project. I've used it myself.
Mm-hmm.
I would be curious to hear, and sorry for putting you on the spot here.
No, it's fine.
Any fun stories from the long history of HTTP archive, like
fun
insider stories.
I don't know. I have a whole lot of insider stories. Yeah.
It's okay.
Sorry.
I guess just based on having seen all this data for a fair amount of time, what's kind of your biggest personal like pet peeve? Like why haven't they addressed this like en masse yet? Is it just the uncached images or anything else?
There's a lot of things. So I did a talk at the Performance Now conference 2 years ago, and the talk was about performance mistakes. So I found web performance features that have been implemented incorrectly, right? So lazy loading done wrong, font preloading done wrong, and what I'm I guess if I had to say like what's kind of frustrating is that like 2 years later, those still the same. There isn't really much movement there.
I even have two questions. First, do we have something about speed? I thought that we have some performance information there too.
There is performance information in the archive. So not only does it collect information about the assets, but like all of the performance timing information. And then one of the cool things that you can do to relate it with speed is kind of marrying the HTTP archive data to the Chrome user experience report data, because you can query across both projects, and then you can wind up looking for websites, like the performance of websites based on certain characteristics.
And second question about what exactly collected from website, because websites are very large, so there is some pages that are dynamically created from database, and
Yeah.
do we get all this information too, and in what way?
So it's really anything that a web browser could see. So all of the HTML, JavaScript, CSS, fonts, all of the assets that are delivered to the web browser. That includes third-party content as well. So anything that's loaded for that particular client that is crawling at that time, that gets archived.
Hey, I have two questions. One might be more fun than the other.
Mhm.
For first is any like fun name and shame like factoids, like that website is like really doing this thing that's really bad. I guess my second question is kind of similar to what the previous person just asked, right? Like,
Yeah.
I work on a site where it's a logged in experience, and like I imagine like these crawlers can't get to that.
Yeah.
So
Right.
like, yeah. So the data is just for
Yeah.
like public.
Yeah, so the data is for let's say for your company's website, it might have the homepage and a login page. Like it might not have the data that's behind the login because it is only collecting public information. As far as name and shame, that's not my style. I did when I did the performance mistakes talk, I did share very specific examples of websites that were doing things that we could learn from, because I look at it more as learning experiences rather than kind of shaming a website.
Say a colleague comes up to you and says, "Paul, I'm scared of SQL queries." What would be your quick trick you would tell them how to shrink their SQL queries?
There's how to shrink their SQL queries. So I guess that really. I'm sorry?
So it processes less data.
Oh, so it processes less data. So with the HTTP archive, I basically would say to add more conditions in your where clause, so that you're kind of trimming down the amount of data that's being processed, and that you can actually see in the console. Let me actually show you real quick. I always hate how this thing hides the. Okay, cool. So like this is processing 741 gigabytes worth of data, but if I change the rank to, let's say, the top 100,000 websites, it's processing 4 gig of data. So like when I'm writing queries, like if I'm writing queries to put in like a blog post or a conference talk, I'm going to start with 1,000, and it is like hardly using any data. And then I will, once I know that the query works, I will increase it or remove this condition, and then see the results.
And you can see that number before you run the query, right?
Yeah, you can see the number before you run the query.
Well,
And then after you run the query, you could look in job information and see the actual number of bytes that were billed.
Before I pass on the mic, I have a question. You mentioned Chrome user experience report a few times. Can you tell everybody what that is? Because not everybody might know about it.
Sure. So the Chrome User Experience Report is Google's RUM data. So if I go to, so the Chrome User Experience Report is data that Google collects. It's performance data that Google collects from websites. Basically, all those websites that I was showing you, like the 17 million websites, they're collecting this data from Chrome users that have opted in for anonymous usage statistics reporting. So they wind up collecting the performance of the websites that real people are visiting, and they aggregate that and they publish that and they make that available for anyone to access. There's a really cool website called CruxViz, where you can take any website, and I'll use my company's website, and you can actually see like what the core web vitals are. So the largest contentful paint, the interaction to next paint, and the cumulative layout shift. You can go and look at that for different metrics. Like, you know, our largest contentful paint is really good, but our time to first byte there's definitely some room for improvement. We could look at this for specific URLs. So this is just for the homepage. Maybe look at this for the search page, right? And you can see that the search page's largest contentful paint has actually gone down quite a bit, and that was actually because of a change that we made. To introduce back-forward caching on the site. This data allows you to basically go and look at performance data for real websites. Like you can look at your company's website or even your personal website if you have enough traffic that it meets their inclusion thresholds, and then you can look at that. You can look at that data, but in BigQuery you can actually run SQL queries against this data, and you can look at this data in aggregate across a larger population of the web. There's also one other website that I use. It's called trio.sh, and it's same data. So they pull in Chrome User Experience Report data, but it's a slightly different view. So like you can see like the different navigation types and the form factors and so forth. But then you can go and look at this for any site. So like let's say we're here at Cloudflare. Let's take a look at Cloudflare's website. So it looks like there was first contentful paint whoopsie that happened somewhere in September and is recovered. Interaction to next paint has been improved. Like all of that data is public for any website that you want to look at.
Yeah, question on, you mentioned before about a couple of things that from your Prof Now talk a couple of years ago about bad implementations or implementing them wrong. Do you mean by the developers or by the browsers?
By the developers. So I had put together like 17 common mistakes that I found. So one of the ones was around lazy loading images. So if you lazy load images that are like largest contentful paint images or images that are above the fold, then that will actually affect rendering time. I found that there was 731,000 websites that do that, and when I ran that again, it's more. And then like I included the names of websites that were doing this. It's large and small websites, but like I found a whole bunch of things that examples of pre-connect being implemented incorrectly. 4.6 million pre-connects implemented incorrectly. Preloading images, preloading large number of requests, preloading video files, things like that. Like there's.
Jen is telling me that everybody will be interested in hearing this talk in June. Am I right?
In June, I could do it again. I can update the stats. If you're not all bored with me after this talk, you'll definitely be bored with me at the end of the next one.
Nobody's bored.
Okay.
Sleeping.
No one's sleeping? Okay. It's nighttime. We could do like bedtime stories now. We've got the sunset and everything.
Paul, I had a couple of advertising related questions. I was wondering, does HTTP Archive have any insight into or do you have anything to kind of say just about the effect that advertising has had on blowing up those page loads over time?
We could. So that's a tough one because, I know that there is a third-party data set. I think Patrick Hulse, Google had created it. We could look at different types of third parties, and we can I think it's up, not from like way back when, but like as of a couple of years ago, we could look at like different types of content. So whether something was analytics or advertising, but then like get a sense of like how much page weight is associated with just advertising content.
Yeah, that was going to be my other question. Like, can you break down like what's from ads versus what's like? Is that something that's easily done through like a SQL query or something?
So yes, we would just need to. Let me actually see if it's in here. Yeah, so there's it's under Lighthouse infrastructure. So this is a different data set, but there's like a third-party data set where I could actually. It looks like it is probably out of date, but there's essentially a data set that has third parties categorized by the different types of the different types of content that they're hosting. Yeah, I'd have to check and see if there's a more up-to-date version of this because 2023 is pretty old. Do you remember the website that was? I think it was like thirdparty.info or something. I don't want to randomly open up a web page.
If you are in
That's
this,
dangerous.
In this space, you might have your own data that you can marry with, right? Or release it publicly for everybody to enjoy.
Yeah. But if you want to dig into that, reach out to me. Like, let's connect later, and we can go and like dig in and see what we can find. Cool.
I have a follow-up to the Crux question. So what's the point of having both HTTP archive and Crux? Like, are they collecting different data? What is fundamentally different between them?
So the Crux data is collecting the performance data for real users. And when you're looking at real user data, you can only collect certain things, like things that, like at least with the Chrome User Experience Report, it's things that come from browser APIs. So like you're only going to be able to get timing information out of that. The HTTP archive and the Chrome User Experience Report is based on a large number of experiences. The HTTP archive is based on one single user's experience, and that single user happens to be a Google Cloud agent in California, or a few hundred of them, because 60 billion tests is a lot. So like that's collecting pretty much everything that you'd collect if you had Chrome DevTools open. So like the performance timeline, all of the networking requests, and the response bodies for everything, and the response headers. So you're never gonna get that with a Roam tool because it's just too much data to collect at scale. But the HTTP archive gives you all of that data that you can query. So it's two really like separate data sets that are used for different things.
Can you run any runtime AI queries for us?
I can.
Maybe. Who wants to know something?
What do you want to know?
Folks?
Well, you asked the question, so I'm going to put you on the spot now.
Okay.
Do pages of different languages have different sizes when loaded?
That's a good question, and we wouldn't have that in the HTTP archive.
However, you could probably analyze every body of every HTML page, but it would be very lengthy exercise.
So before I was showing you JavaScript frameworks, so if I say like based on the HTTP archive data from last month, what are the most, typing is hard, most popular frameworks? Let's say JavaScript frameworks. You can see that it's kicked off queries. Here are the most popular JavaScript frameworks, right? And you can ask follow-up questions like, show me the core web vitals for these frameworks. And so now it's going to query the HTTP archive data, but cross it with the Chrome User Experience Report data. And here we go. The pass rate for React is 54% on desktop and 42% on mobile. We can see that the pass rate for React on desktop is actually quite high for largest contentful paint. Yeah, that's interesting. Time to first byte. We could like show me the.
The question is, what does it measure as the time to first byte for React website? Right? Like, is it a static HTML that did nothing, or is it the full-on server-side render or is it a CDN cache? Those are the questions you can answer with HTTP archive queries.
For React sites over the past 2 years.
And did you say there are monthly reports, monthly collections?
Yeah, it's monthly. And a lot of this, like you can get from looking at the website, like you can go and like filter in through the tech report and get some of this. This is just cool because it's AI. And so far I've spent 7.5 cents. So fun times. It is envisioning. I've been learning so many new synonyms for processing from Claude. I don't know if everybody else feels the same way. But yeah, here's time to first byte. So the time to first byte, the pass rate's actually been getting higher over time, which is interesting.
Nice. Good news. Something is
Yeah, something's improving.
How do you guys aggregate all the HAR files? Is it an API in the browser that forwards them to you? Do people submit them? Do you have a botnet that kind of just scrapes the internet every once in a while and shows them in your DB? What's the ingestion and aggregation like?
So there's a BigQuery pipeline that's running in Google Cloud, but it's basically what we're doing is the web page test is running. So we have like all these web page test measurements run. The results are these large JSON files that are like HAR files that get stored into Google Cloud Storage. And then there's a processing step that will go and split that up into individual requests and pages and store all of that in BigQuery. And then all of that data gets stored into all of that data gets like loaded into those two BigQuery tables, and they're available for processing. And then after that, there's another job that runs that goes and creates all of the visualizations for the website, as well as the tech report and so forth. All of that data is in, because it's open source, the whole pipeline for this is in GitHub HTTP archive. So if you go to the HTTP archives GitHub, it should all be in the repository. There's a BigQuery dataset, a BigQuery one. I think it's the BigQuery one. It might be Dataform now. Yeah, I think it's Dataform. So I have not worked on this specifically, but like all the code for doing that is here. Sure.
Can you disambiguate the words HTTP archive as the website and HTTP archive as a file format? Is there a relationship between the two?
I don't know which came first. So yeah, I'm actually not sure which came first.
But the good news is there is a format that you can export. The HTTP archive format, HAR file, you can export from Chrome developer tools if you like. So you can easily look at how that data looks like by just opening the website and exporting the file. Huge JSON, huge.
There's also a tool that was just introduced, is it waterfalltools.com? Yeah, so Pat Meenan had just created this tool where you can take like a DevTools trace. Why don't we do that? I'm gonna go and load my company's website.
We didn't pay him enough.
Okay, we can choose a different website to look at. I'm just trying to be nice.
So Mike is just eyeing me because you can use Telescope for that too.
Sorry, Mike. Much love. Okay, so I've just loaded the page, 1 megabyte of transferred content, but here's the HAR file. So I'm gonna go ahead and download the HAR file. Here we go. So this is 11.6 meg.
11 megabyte of data from one page load.
And this
doesn't matter how big the website is, it's a lot of data.
And yeah, so it looks like there are a couple of beacons that fired later, but if I trim this to 4 seconds, then you wind up seeing kind of a waterfall graph that just shows you like what was collected from DevTools. There's our advertisements. Let's see the largest contentful paint image. So forward request and response headers, it basically just takes all of the data from the browser and allows you to visualize it. But if you look at the raw details for any of these individual requests, this is the type of data that gets stored in the HTTP archive. So in this case, you can see the URL, the method, the status, the headers, and then we've got request headers and response headers. The MIME type, the number of bytes for every request, yeah. And like if we go and look at the HTTP archive data, so if I click details, I can see that this data set is 9.5 petabytes of data. But if we go and preview it, like you can see the data that's actually stored in it is for every single request on these pages, you got the rank. Is this a main? Is this the main document? No, this is an audio file. And then there's the HAR file. So all of that data can then just be queried out by extracting it from the JSON. But then there's request headers, response headers, and the response body is null because this is an audio file. But if it was a CSS file, then there would be a response body in there.
A lot of data.
A lot of data.
And you can use Telescope open source tools to collect that.
Yep. Yeah, and I think that UI, so the waterfall tools, can take so Telescope outputs Chrome DevTools traces, right?
No, it's actually, we collect our own stuff, but it's HAR file, metrics, basically from browser APIs.
Okay.
Because it supports both Safari and Firefox on top of Chrome, so that's another advantage. So,
cool. I don't have it installed right now. I hope I'm gonna get a duck and hide from Mike. But
That's okay. You know.
The look of disappointment.
Is there a meetup maybe where anybody can bring their website and we help them do something about it?
There is, yes.
When is the next one?
April 30th, and it's going to be at Etsy's office.
Yeah, so Meet for Speed. You can bring your website, you can ask your questions. And
And so unlike this session, which is like a presentation style, the meetup at the Meet for Speed meetup, we're basically sitting around a conference room table and just someone's going to share their screen and we're gonna find ways to make the website faster. We had one person that came a couple of months ago and we wound up finding features on a service that they were using that weren't enabled, that was able to make their images half the size and did quite a speed up on the site. But yeah.
We do have some good stories. Business Insider wrote an article about us doing that.
Did they?
A while ago.
Okay.
But, I think Business Insider is still alive, which is good. Okay, thank you, Paul.
Thank you.